SQL fundamentals. Cybersecurity is a broad topic that covers a wide range of subjects, but few of those are as ubiquitous as as the database. Whether you are working on securing a web application, working in a as what is this? Security Operations Center, and using security information and event management, configuring user authentication, access control, or using malware analysis, threat detection tools. The list goes on. You will in some way be relying on the database. For example, on the offensive side of security, it can help us better understand SQL vulnerabilities, such as SQL injections, and create queries that help us tamper or retrieve data within a compromised service. On the other hand, on the defensive side, it can help us negative truth databases and find suspicious activity or relevant information. It can also help us better protect a service by implementing restrictions when need. Restrictions. Because databases are ubiquitous, it's important to understand them, and this room will be your first step in that direction. We'll go through the basics of the database. Covering key terms, concepts, and different types before getting to grips with SQL. Okay. Okay, so you've been told just how important they are. Now it's time to understand what they are in the first place. As mentioned in the introduction, databases are so ubiquitous that you are very likely interact with systems that are using them. Databases are an organized collection of structured information or data is easily accessible and can be manipulated or analyzed. That data can take many forms, such as user authentication data, which are stored and checked against when authenticating into an application or site, like TRYHACKME, for example. User-generated data on social media, like Instagram and Facebook, where data such as user ports, comments, like etc. are collected and stored, as well as information such as watch history, which is stored by streaming services such as Netflix and used to generate recommendations. I'm sure you get the point. Databases are used extensively and can contain many different things. It's not just massive scale that use databases. Smaller scale businesses, when setting up will almost certainly have to configure a database to store their data. Speaking of kinds of databases, let's take a look now at what those are. Different types of databases. Now it makes sense that something is used by so many and for relatively so long that there will be multiple types of implementations. There are quite a few different types of databases that can be built, but for this introductory room we are going to focus on the two primary types: relational databases, SQL, versus non-relational databases, NoSQL. Relational databases, table-based; non-relational databases, key-value, graph, document, bytecode. Relational databases store structured data, meaning the data inserted into this database follows a structure. For example, the data collected on a user consists of first name, last name, email address, username, and password. When a new user joins, an entry is made in the database following this structure. This structured data is stored in rows and columns in a table, all of which will be covered shortly. Relationships can then be made between two or more tables. Hence the term relational databases. Non-relational databases. Instead of storing data the above way, store data in non-tabular format. For example, if documents are being scanned, which can contain varying types and quantities of data, and are stored in database that calls for a non-tabular format. Here is an example of what that might look like. Okay. Object ID. In terms of what databases should be chosen, it always comes down to the context in which the database is going to be used. Relational databases are often used when the data being stored is reliably going to be received in a consistent format, where accuracy is important, such as when processing e-commerce transactions. Non-relational databases, on the other hand, are better used when the data is received can vary greatly in its format, but need to be collected and organized in the same place, such as social media platforms collecting user-generated content. Tables, rows, and columns. Now that we've defined the two primary types of databases, we'll focus on relational databases. We'll start by explaining tables, rows, and columns. All data stored in a relational database will be stored in a table. For example, a collection of books in stock at the bookstore might be stored in a table named books. primary and foreign keys. Once a table has been defined and populated, more data may need to be stored. For instance, we want to create a table named authors that stores the authors of the books sold in the store. Here is a very clear example of relationship. A book stored in the books table is written by an author stored in authors table. If we want to query for a book in our story, but also have the author of that book returned, our data would need to be related somehow. We do this with keys. There are two types of keys: primary keys, foreign keys. Okay. What database should you consider using if the data you are going to be storing will vary greatly? Okay, this could be non-relational database. Okay. What type of database should you consider using if the data you are going to be storing will reliably be in the same structured format? This is relational database. In our example, once a record of a book is inserted into our books table, it will be presented as a in that table. Once record of a book inserted in our books table. Which type of key provides a link from one table to another? This is foreign key. Which type of key ensures a record is unique within a table? Unique. This is primary keys. In our example, once a record of a book is inserted into our books table, it will be represented as a row. What is SQL? Now all of this theoretically sounds great, but in practice, how do databases work? How would you go and make your first table and populate it with data? What would you use? Databases are usually controlled using a database management system, serving as an interface between the end user and the database. Is a software program that allows user to retrieve, update, and manage the data being stored. Some examples of these include MySQL, MongoDB, Oracle database, and database. The benefits of SQL and relational databases. SQL is almost as ubiquitous as database themselves, and for good reason. Here are the some of the benefits that come with the learning and using the SQL. It's fast, easy to learn, reliable, flexible, getting hands-on, start machine.